Assalamualaikum all and welcome to the next class. As you know, in previous class we had started exercise 20.1. Before solving these questions, please do subscribe my channel. Now question number 1, three parts we had done in previous class. Now from part 4 we are going to start this lecture. In this question we were finding the nature of the quadratic equation by discriminant. So first we rearrange the equation if needed. So it will be 9x square. We are rearrange according to the power of variable. So we have rearranged it. Now we will use discriminant to tell the nature of the root, which is equal to b square minus 4ac. Here you can see a is equal to 6, b is equal to 9 and c is equal to 1. Now let's put the values in this formula. So it will be delta is equal to b square means 9 square minus 4, a is 6 and c is 1. So it will be 81 minus 24, and by subtracting you will get 57. 57 is bigger than 0. So you can say if the answer is bigger than 0, then the roots are real and unequal. So you will write real and unequal. Guys, you can also verify your answer by putting all values in quadratic formula. And you know, verification is very easy. You can verify. To verify the answer, we can put all values in quadratic solution, which is equal to minus b plus minus b square minus 4ac upon 2a. Now let's put the values in this. So it will be x is equal to minus b, where b is 9. So it will be minus 9 plus minus b square, again 9 square, minus 4ac, 6 and 1, and whole upon 2a. A is 6. By solving this, we will get minus 9 plus minus 81 minus 24 upon 12. Plus minus 57 upon 12. Now you can see you have proved that the roots are real and unequal. So you can write, hence proof roots are real and unequal. Hence proved. Now the part number 5 is 24x square plus 12x plus 36. Before starting to solve this equation, you can see 24x square plus 12x plus 36 is equal to 0. We can take 12 as common. After taking 12 common from whole, it will be 2x square plus x plus 3 is equal to 0. 12 is multiplying here. When you will shift on the right side, it will be divided by 0 and will be equal to 0. So the now equation is 2x square plus x plus 3 is equal to 0. Now you can tell the formula of discriminant is b square minus 4ac, where a is equal to 2, b is equal to 1 and c is equal to 3. Let's put the values in this. It will be 1 square minus 4a is 2 and c is 3. 1 minus 4 2s are 8, 8 3s are 24. Delta is equal to minus 23. Delta is equal to minus 23, which is less than 0. And if the answer is less than 0, then you can say the roots are complex. Roots are complex. And you can write roots are imaginary. Now let's prove it by verification. To verify, we use the formula x is equal to minus b plus minus b square minus 4ac upon 2a. Let's put the values where minus b is 1, so it will be minus 1 plus minus according to formula. Then b square means 1 square minus 4 ac. A is 2 and c is 3 upon 2 is 2. So it will be x is equal to minus 1 plus minus 1 minus 4 2s are 8, 8 3s are 24 upon 4. 1 minus 24 is minus 23. You know, we don't write minus sign inside root, so it will be minus 1, which is equal to 23 root and iota, because the value of root minus is equal to iota upon 4. So because of iota, you can say the roots are complexed. As iota is the imaginary part, so you can say roots are complex. It's proved. This solution we use to find the nature of the root, and this part we use to verify the answer. Now let's come to the next part, which is x is equal to x square plus 1. Let's rearrange the equation, and after rearranging it will be x square plus x will be minus x plus 1 is equal to 0. Now we have rearranged the equation. Now we find the nature of the roots by the same method, which is equal to b square minus 4ac, where a is 1, b is equal to minus 1 and c is equal to 1. Let's put the values. B square means 1 square minus 4ac. 1 minus 4. 4 1s are 4. So which is minus 3, and it is less than 0. And if the answer is less than 0, then we call it complex or imaginary root. We can write imaginary roots, or you can write complex roots also. Now let's verify it by using the formula minus b plus minus b square. Every time we use this formula to verify the nature of the root. Minus b is, it is already minus 1, and this is the minus of formula, so minus we are going to write it as it is. Instead of b we will write by the value of b, which is minus 1. Again b square means b is minus 1 is square minus 4, a is 1 and c is also 1 upon 2a means 2 1. Now you can see minus minus will be plus 1 plus minus 1 is square 1 minus 4 1s are 4 upon 2. 1 plus minus you will get minus 3 upon 2. We don't write minus sign inside the root, so it will be a imaginary number when you will write iota instead of minus upon 2. Because of iota, you can say this root is imaginary root. Hence, verified. You have verified that the roots are imaginary root because of iota. Now part 7 is 3x square plus 6 is equal to 5x. First, we have to rearrange it. It will be minus 5x plus 6 is equal to 0. Discriminant is b square minus 4ac, where a is equal to 3, b is equal to minus 5 and c is equal to 6. By putting the values, minus 5 square minus 4, a is 3 and c is 6. Minus 5 square is 25. 4 3s are 12 and 12 6 are 4 3s are 12 and 12 6 are 72. Now by subtracting these two numbers 25 and 72, you will get minus 47, which is less than 0. If the answer is less than 0, then we called it imaginary root. We can verify the answer by the same method. Let's put the values. Minus, the value of b is minus 5, so put it, plus minus b square means minus 5 square, minus 4, a is 3 and c is 6. A is again 3. X is equal to minus will be plus. Let's solve this. 5 square 25 minus 72 again. 4 3 are 12, 12 6 are 72. And denominator will be 6. (25 minus 72 is minus 47. So minus 47 means 47 iota. So hence verified that the roots are imaginary. You will verify each part of this question to prove the answer. Now let's solve part 8, which is the last question of this exercise. Last question of question number 1. The question is 3x square plus 9 is equal to 0. Let's take 3 common. If common is possible, then you will take common first. X square plus 3 is equal to 0. When you will divide 3 by this 0, it will be 0. So the equation is now x square plus 3 is equal to 0. By applying discriminant, it will be b square minus 4ac, where a is the coefficient of x square, which is 1. B is the coefficient of x. If there is no x, then it means b is equal to 0. And c is constant. You can see the constant is 3. So by putting values in discriminant, it will be delta is equal to b square means 0 square minus 4, a is 1 and c is 3. 0 minus 4 3s are 12. Delta is equal to minus 12, which is less than 0. Again, less than 0 means complex root, or you can write imaginary root. As I told you, we have to verify each part, so let's verify it by using the formula minus b plus minus b square minus 4ac upon 2a minus b is 0 plus minus 0 square minus 4, a is 1 and c is 3 upon 2a is again 1. 0 plus minus 0 minus 4 3s are 12. 2 1s are 2. It will be, don't need to write 0 plus minus, it is, the number is minus 12 upon 2. We don't write minus with the answer. So it will be 12 iota upon 2. Again, because of iota, you can say it's verified that the roots are complex. You will write hence verified. So this was question 1 of exercise 20.1. You can see I have solved all parts of question number 1. In next class I will solve question number 2 inshallah. Don't forget to like, subscribe and please share my channel. Allah Hafiz.